Oh, haha. Okay, so let's go here. Let's go back to here just real quick for Jaya here. So, I made you guys do this at the beginning of as you guys walked in, right? So here's a few things here. So we'll talk about this a little bit more. But if you take x and y, put it somewhere in space on the x and y grid, we can always find an r value. That r value has to always be positive. X and y could be negative based upon the quadrants, right? And out of these three numbers, we can make six different ratios. Are we good? Agreed with there, right? Okay, so this guy here, doomp, right here, here's where we're at. Hipparchus, there you go. It's Hipparchus. What a name. You guys like name? Hipparchus. No, I don't think so. Bithynia. Uh-huh. So born 190 about, died 120, so about 70 years old. Perfect. The first work on trigonometric functions. Now, the only thing is they didn't think about X and Y grids because that didn't happen until the 1500s. So they always thought about triangles and circles. That's if you were to study the way the Greeks thought about it. It would be different than the way we think about it. It's introduced differently. But here it is. He made the first known table of chords, which essentially is all the different ratios you can make. And he makes these six ratios. And he's like, that's cool on a Saturday morning. But he doesn't know it yet. But he actually starts trigonometry, essentially. That is it. And so now we start from there. He makes tables out of it, which we'll do as well. And we'll start a whole new trigonometry here in just a bit here. Whole new branch of mathematics that has never been done before. So I put in some other stuff here. That's okay. We'll skip that for now here. So the other thing that I want to show you guys is this right here. And why this? This is a cover to a book. It's Gödel is I think a German philosopher. Escher, he did a lot of stuff. He's a mathematician by trade. He also did a lot of visual arts inside mathematics. It's kind of cool. I should show you his drawings. And Bach, music, is that good? And so the reason why I show you this is kind of cool. There's two wooden pieces. And it looks like there's a string that's holding them right here, right? Looks like. But if you shine a light this way, it makes the letter E. Shine the light this way, the same direction, it makes the letter G through the wood. If you shine the light from the right side, it makes G and E this way. And if you shine the light from top to bottom, it makes a B. We good? Kind of cool, but it's the same wood. It's just etched in a different way. Why do I show you this? Is because in trigonometry, we're going to have three different definitions of trigonometry. Cool. So depending which one you need, you're going to use that one. Cool. And so it's going to be a little confusing. How much is when you kind of see it like, oh, if I'm doing this, then I don't need the R value. If I'm doing this, then I do need the R value at that point. We good? Just so we know. Okay. So that was kind of cool. But again, so this is going to be something called the first definition of our trig values. And let me see how I have this lined up. Yeah. That's cool. Here's a fun part here. Here's the way they thought of trigonometry right here. Cool. So here's an arc. This is how long this thing is across. This is the sine. We'll talk about that in just a bit here. And the chord is a double arc, and then see how far it stretches here. And this is cool. This is, I think it's from the 1200s. This is a rendition of his book, Hipparchus's book, that was recovered. And there's his name right there. That's cool. Bra. That's kind of cool. But anyways, some historical fact. I think it's sitting in some museum in London. Obviously, haha, yeah. But it was kind of cool that actually we have a manuscript from that late. All right, with that, let's go. So 1.3. So what we're going to do today is I'm going to get through as much of 1.3 as possible. Then on Friday, we're going to try to just go a little bit slower, catch up on any 1.2 homework you may have. We're good. And then any 1.3 homework. Maybe we just use it as a homework day-ish. Cool. All right. And then I have sent out ballots for the poster contest. I have received 2 out of 8 back. So a fourth of them have to return back to me. So hopefully by the end of the day, Well, the rest of them will be returned back. Say again?
Which one?
Can't say. It's classified information. Let's go with it. So definition 1 of the trig function.
For ballots handed to different people in the class, or
Say again?
for ballots handed out to different people in the class, or like, am I?
Teachers. Teachers.
Oh, it's teachers.
Oh,
Okay.
teachers. Yeah, sorry. Yeah.
I was confused for a second.
Gotcha. All right, let's jam. So here it is. Oh, look at this. The same exact stuff over here. X and Y and R. We got theta happening here. That's cool. All right, so here's what we do. We're going to name a function, and the function is going to relate the angle. Notice we have an angle here. We want to connect this. We want to connect the angle to the ratios. And so we just call it different things. So first one, we're going to call, and then we're going to abbreviate them to be a little bit more faster to write. And then we're going to write the ratio to them. Cool. So this will be the long slide here. And keeping my time. And we're going to jam, because we're going to try to get through most of this quickly. All right. Ask me questions as we go. Otherwise, let's go. So the first one, we're going to call this sine of theta. So notice it is, I have to name it some kind of function. The abbreviation of it, let's do this just to simplify. How about we just use the first 3 letters of the function name? We good? So we're going to call it sin, and then we're going to put a theta next to it. So it's sine, we don't call it sin, it's sine theta. And what's the ratio? We're going to call that ratio the y over r ratio. So the Hipparchus, not only does he do the ratios, then he makes a name for each of the functions. And the fun part is, this one is kind of like the main function, and everything goes off of this one. And throughout history, when Hipparchus actually named it, he named it a certain way because it has to do with circles and a triangle, right? Triangle and circles, right? And so we'll talk about that in just a bit here. Okay, so we got this one. So then we also have the cosine. That's interesting. Which letters are we going to use? Cos. Perfect. Perfect. We just started here. So first slide. So Hipparchus makes this. He starts naming sine. He just starts naming functions. I'm going to name this sine function, abbreviation, and then he sets the ratio for him. Okay. Technically, we'll talk about this here, but there's a connection between sine and the co of sine. We'll see what that is. But he names it cosine for sure. Cool. Next one. Says, okay, I got y over r. That's cool. I got x over r. So I'm going to do y over x now. So he calls it tangent of theta. Tangent of theta. What 3 letters are we going to use? TAN. Y over x. That'll be our ratio. Cool. Next one. And then we have the co of tangent, or cotangent. And the letters. Okay, so the fun part is, I was looking on YouTube and I was listening to British mathematicians. And in America, we always say cotangent. No matter, you see COT of theta, you say cotangent theta. But in Europe, yeah, they actually say cot. Cot theta is, back to the British accent, of course. I thought, whoa, that's weird. We don't do that. Okay, so we got tangent, cotangent. And then we have, next one is secant. Secant of theta. What letter should we use? SEC. Now, the only problem is this one in American language, right? SEC also stands for seconds. So if you're doing physics, you got to be kind of mindful what you're doing now, right? Are you looking at an angle? Or using secant function. If you talk about time, using that one. So now let's flip this around. So r over x. All right, so let's see. Let's look at the pattern here. Sine and cosine, tangent and cotangent, and secant and cosecant. All right. And here's where things go bad. What is bad? Yeah, if you do the abbreviation, you're going to find out it's the same one as the second one that we have. So the mathematicians struggle with it, they arm wrestle and all that stuff. And they finally come up with what's going to happen is, so they decided, just the decision we made, ready? They said, okay, we're just going to take the first three consonants, not vowels, but consonants. So CSC, we good? So whenever you see CSC, you don't say you say cosecant. Now in British, I'm not sure how they do this, right? Because if they do cot, right, and sec for this one, I need to see what they actually do with that. Didn't find a video that had that in there.
Mr. Shots, they just don't say in the consonants.
Oh, that's true. Okay, yeah. They just blah, blah, that one. That's the function. Okay, what's the ratio? So I got y over r, I got x over r, da da da, r over y. Okay, according to Hippocrates, that is it. There's only 6 ratios. We got ourselves our 6 trig functions. Cool. Based upon that, we have now a whole new world of mathematics just started. We good? So what is the definition? Definition is the connection between x, y, and r. And it's flattened onto my x and y grid, right? So x and y grid, there's an angle that's flattened on top of it. And the origin is at the vertex, or the vertex is at the origin. Okay, one little fun part. We got to do this one. This little guy right here. In mathematics, the sine is a trigonometric function of an angle. The word sine is Latin, comes from sinus, comes from the Latin mistranslation of the Arabic. I know, shucks. No. All right, so it's the Sanskrit word should have been half chord. That's what that word. Anybody want to pronounce that last word there? No. That's best I could do too here. Okay, so that is supposed to stand for half a chord. And then the sine function sinus, what does that stand for? It doesn't give it to us. So here it is. Here's my little so at the end of the semester, what you guys will be required to do is you guys will be required to do like just a presentation on any topic of a mathematician if you want to. We good? The other part is anything that we've covered in the textbook that you're like, I want to dive deeper into this, was just kind of cool. Or anything that's related to you and like your life and trigonometry. We good? But the second part here, if you did want to you like history, you like words, and you want to kind of delve into this whole mistranslation piece, you can do that towards the end of the semester and kind of do a whole presentation on it. We good? That'd be kind of one of those like, oh, that is so cool. Dive deep into it. Why was it translated this way? What does sinus mean in Latin? How come it got translated? Who did it? All the good stuff. Okay, so let's jam. Let's do trigonometry finally. Da 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 da. Example 1. State the 6 trig functions based upon this guy. And of course, we're going to learn some stuff. So can you graph this? And after graphing it, can you put down all the 6 trig functions? Let's do this one together, of course. Okay, I think we'll learn a lot as we go through this here. I keep time as well. First things first, let's graph this. So you guys tell me which quadrant is -1, 3 going to be in? 2 is right. Quadrant 2. All right, since we don't know what the angle is, we're going to just put sine theta. We good? Cosine theta. So notice on the previous slide, there was parentheses. This one does not have parentheses. Does not matter. Sometimes they put parentheses, sometimes not. It kind of doesn't matter. Properly, you would put parentheses. If you have numbers, you for sure put parentheses. Okay? But then it's like, do I know what I'm talking about? Yeah. So forget the parentheses. So sine, cosine, tangent. cotangent, secant, cosecant. There it is. So there's my 6 trig functions. And let's jam. And you guys tell me if I'm going too fast. We're good? So quadrant 2 is what I got. I got my little dot right there. Is that true? I'm going to label my x and y coordinate. And I'm going to have to, oh, remember that little curvy, right? Remember that curvy angle. It tells me the direction my angle is going. It starts at my initial side and goes always to my terminal side. Something's happening there. All right, so how about a negative 1, 3? And then guess what I need to find? Yeah, I gotta find the r value because I'm only given x and y. And it is really just this right here, right? Is the square root of the x coordinate squared plus the y coordinate squared. Kind of like the distance formula, right? But then it's just from the points themselves. So what do you guys say here? That's 1, 1, and 9. Oh, if you need the formula, here's the formula for it right there. R is equal to the square root of x squared plus y squared.
Right.
Cool. Boom, boom, boom. And got myself, I guess, a 1 plus 9. Is that right? 10. Can I simplify 10? Yeah, made up of a 2 and a 5. No, that's it. Okay. So let's put our ratios together and we are done. So let's do this here. Just start from the fun of it here. We'll start in the middle of the room, work our way. So Lucas, I'm pick on you. That okay?
Yep.
Sine of theta. Give me the ratio.
Square.
Perfect. Okay. So just real quick here, just so you guys know, in algebra class, you would have to rationalize your denominator. Trigonometry class, we don't matter that much. We good? So you can keep it like that. If you want to keep it as 3, if you want to rationalize it at 3 root 10 over 10, that's fine. This is just perfectly fine. Okay, any questions on that one as we do the first one? The second one, Anya, all yours. Perfect. Negative 1 over square root of 10. Perfect. That's an all yours.
1, 3.
Perfect, yeah. So 3 over negative 1. Now this one, because the negative 1 is on the bottom, this one we do simplify. We good? So in this case, it'd just be a negative 3 as an answer. We good? All right. Cotangent Gavin.
Cotangent x over x is negative 1.
Oh yeah, perfect. Negative 1,
Negative
over.
1 over 3.
Perfecto. Yep. You got it. Negative 1 over 3. And it's just a flip of that one, right? Flip of the original one. Perfect, Milo. All yours when you're ready. Secant is. And if you don't know it, that's fine.
Yeah.
That's why we're here. That's no problem. So secant, let me work our way through it here. So secant, by our definition that we have on our page, I look back at my previous slide, it's r over x, right? So r is going to be root 10, because that's my r value by definition. And then for secant, the denominator is x. So then I go back over here, look for my x value, which is negative 1. Okay, is that good there? And because negative 1, you do have to reduce this down to a negative root 10. So whenever you have ones or negative ones on the bottom of fractions, we are going to simplify that out. And next on the list. Natalie, all yours. Perfect. Yeah, square root of 10 over 3. This one just stays just like that. It's cool. It's even rationalized already in my denominator. Done. Are we good? Cool. Okay, so I'm going to make you guys do it a little bit more. You guys have to say the name of the function. Say sine of theta is, and then tell me the answer. We good? As we do the next one. Okay, and we'll learn some stuff from it.
One.
Yeah, I think so. Yeah, but okay, we're good. That is A. Let's go with B and C. B, 3 and 4. Quadrant 1. So I give you guys about 2 minutes here. And you guys, and then we'll kind of do it really quick here. So 2 minutes to do the problem. I think it's some angle that you guys already know, familiar with. I just want to say you guys are cool to teach. I enjoy teaching you guys trigonometry. I always say I don't teach trigonometry, I teach you guys. We're good. So it's great. So part of it is that if you don't understand something, you're really struggling with something, please come talk to me. But these time things that we like have like some kind of, like Jeopardy or theme song. Dun, 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 dun. I gotta do it. I gotta do it now. Go ahead. So as you guys finish up with the Rob. Jeopardy theme song? No? Gavin says no. Fine, fine, okay. I'll just sing it myself. I just want to walk around and see where you guys at as well. So no.
Oh, yeah.
Got you. So, what do you say 3-4-7? Being good. You get on. But instead I got and we'll have a future. So my yeah, so the two rich, the two people to each other, but it's still. Yeah, so sorry. All right, guys, I added one more to my collection that I brought from home. This is kind of cute. Student gave this to me at the end of last year, and it says, "Thanks for helping me grow." And when they gave it to me in the summertime, it was like this tall. It was just this small thing, and it's grew even during summertime. But I thought I've got to go with some my adding collection over here. Cool. I see most of you guys are almost done. So here it is. You're gonna have to say sine of theta is, and then give it to me. So 3/4. I'm gonna wait on that just for a little bit. Don't forget the 6/8 in just a second here. So sine of theta is, cosine of theta is, tangent theta is, cotangent of theta is, secant of theta is, cosecant of theta is. 1, 2, 3, 1, 2, 3, 4. Builds that little guy in quadrant 1. Builds a little triangle, technically, right? Is that a little triangle that comes down? It is technically a right triangle. We also have to put that little circular arrow saying which direction we went. And you got to name the theta, right? Name the angle. If you have more than one angle, we'll label it as alpha and beta or A and B, whichever. But you got to label what we're talking about. And I'm just going to write these a little bit later on. We'll talk about those in just a second here. What did you guys get for R? 5, of course. 5 is R. The coordinate is 3/4, 3, 4. And, well, all yours. Go. Sine. Perfect. Brooklyn, all yours. Perfect. Awesome. Sam, all yours. Tangent.
And theta equals, wait. 4/3.
4/3. Yep. Tangent of theta. We still say the whole entire name, basically. Yeah. We'll go. Perfect. Cool. Aramis, all yours. Perfect. And Ian. Perfect. Okay, cool. Yeah, just part of learning stuff when you verbalize stuff, it actually makes sense to you as well, right? So that's part of that. Okay, so now I got a little interesting trick to you guys here. So the 3, 4, notice what happens to the 3 and the 4. I just multiplied those guys by 2. I've made myself a similar triangle. Are we good? So I want you guys to, now that I doubled my X and Y values, I goes 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. Can you guys solve that one and see what interesting thing surprise happens? Go. Done. Cool. And some people are done. All right, so when you guys, okay, in a minute here, I'll ask you what the R value is. I'm not going to say it now. Don't say it now. Just give you like 2 minutes here for others to figure out. All right, so something interesting should pop out in just a bit here. Abel got it already done. What is the interesting thing?
It's same ratio.
Same, the same ratios come out? Are you sure? Okay, let's go with it. Let's do it together. So 6, 8, and if you take the R value and try to figure that one out, it's going to be 6 squared plus 8 squared, and 6 squared is 36. 36 plus 64 makes 100, is that right? Square root of 100 is? Nice, 10. Okay, so here's the fun part now. Sorry, letting you guys catch up here. A few of you guys still need to just kind of draw it out. That's fine. Go for it. No problem. So did anybody actually ever this? Did this is a goal long time ago and land far away. I used to do this here. Um, I used to we took pictures. We went to Costco because Costco was the cheapest to develop pictures. These guys here. Everything else was like twice as expensive. Costco would just run it for like what, like 30 cents for pictures. So then the fun part is my parents would also go to Costco. And just for the fun, it was like an honor system because all the printouts, right? They were sitting there by last name. That was it. You just came up and you grabbed yours, right? And that was it.
Else so that you like.
But everybody else's was there too, yeah. So then I always mess with my parents because they would go too. And I used to pick out theirs, take theirs, snatch theirs until they call me like, my pictures are missing. My pictures are missing from Costco. Then they figured out I was taking them. So then when they saw it missing, they'd just call me like, hey, you have our pictures. A weird day though, right? Just the honor system, just like, hey, there's like some like we'll drive up at AG and there'll be like family farms and farms, right? And they just have all this produce, right? And it just says like this is the prices for it. It's not banned. Like just put the dollars in, take your eggs, and it's like that's cool. That's a cool thing. Okay, let's go with it here. So hope you guys have figured this out. This is let's see, this is y over r, is that right? And what happens here is you get a 4 over 5. What? It's the same ratio, is that right? So making the doubling the x and y values also double the r value. But by doubling them, the ratios still remain exactly the same when you put it back into fraction form. So this is 6 over 10 or 3/5. Is that right? So then do we need to finish off the problem or we just copy from B? Copy from B. Why do more work than you have to? So 4 over 3, 3 over 4, 5 over 3, 5 over 4. We good? Good there? So to answer your question here, just because fractions, the way fractions work in our world, right? 8 over 10 is the same ratio, right, as 3 over 5. And essentially what you have is then you find out this rule, this is what's really happening, is you have yourself a triangle like this, which is a right triangle. You got yourself a theta, right? And the length here, and this really comes from geometry. If you have another triangle like this, whoa, where did it go? Craziness. Okay, there it is. If you have another triangle that's similar, in geometry we learned that was very important in geometry, right? Because you can actually if you make similar triangles, you can figure out the other side of triangles, right? So if this is X, this is Y. And let's say this is 5, but the whole thing is 7, right? Whoa, again, 7. So then 5 goes to X, just like 7 goes to Y. So then it becomes off of that. But what I want you guys to notice, what Packrus noticed, is this. Is the angle exactly the same?
Yeah.
Yeah, the angle is exactly the same is because the initial side, right? The initial side, the angle is still starting from the initial side. And in order to make similar triangles, this angle has to be exactly the same, right? Because the terminal side just extends. That's all it's doing. It's extending. So, okay, hold on. Let me see if I get this right. If I have the same angle, I'm going to have the same ratio. Are we good? Cool. Okay, let's jump to the next one. D. So 5, 5. Whoa, hello. I think the projector just died.
Mm.
No? Why did you
Projector got a little maybe. I think it overheated.
Yeah, let's see. I'm gonna turn it off just for a second. Let's see if it turns off. Okay, as you guys have 5, 5. 5, 5 are the coordinates. Can you build that? Figure out the angle measurement. Oh, sorry, not the angle. Can you figure out the trig functions? The coordinates were 5, 5. 5, 5 are the coordinates. Okay, we might not have a projector. We'll see. I'm gonna try it one more time and then we'll see. If not, then we'll just do it on the board here. Cool, like that. Let's go low tab. All right. Let's see. You should be able just to solve for R, is that right? Okay, and then puts a trig function. Yeah. Oh, yeah, so yeah, square root should be simplified. And it'd be 25 times 2.
Yeah.
And then you got yourself your 5 and 5 as the perfect square, and 2 is the leftover.
Then maybe like for two.
Oh, yeah.
It's like, yeah, because you take out these 3 5s and bring it outside.
So I would turn on the lights even brighter, 5 would make it 1. Wow. Ouch. Okay, I'm gonna do this here. I'm gonna scoot. Yeah, it's not turning on here. I'm going to scoot this over this way, just so I can still record. And I'm going to be doing two things here. That's fine. Okay, on the board. Oh, now it wants to. Now it wants to be nice. Mm-hmm. Okay. Let's see if it likes the computer then. Oh yeah. Okay, cool. Back in business. So good. So let's jam. 5-5. Hope you guys did this. Hope you guys graphed it. Hope you guys put a dot there. Hope you guys did. Oh, what? How come I put sine of 45?
Oh, because we know the angle we're gonna
Oh,
be-
I know what the angle is now. That's right. So 5-5, if I were to think about the angle measurement. Now, do you have to put 5? No, you don't. If you put theta in there, that's fine for now. We good? So if you had theta, that's fine. But I want you guys to notice that right there, right? So technically, a 5-5 produces a 45-degree angle because the numbers are exactly the same. And you are right in the middle of that right there. We good? So you could put theta, you could put 45. Doesn't matter. My thing is, did you guys get a 5√2 for your R value? All right, so R value over here, back to your little formula. X squared plus Y squared formula gets you the square root of 5 squared plus another 5 squared, which is 225's being added together, which makes 50. And 50 is really just 25 times 2. And there's your perfect square of 5's. So 5's get to go out, the 2 has to stay inside. Are we good? Cool. Okay, I got it. This is cool. So now I got myself sine is, again, what? Sine is, what's the ratio?
Or Y over R.
Y over, okay, Y over R. So Y is 5 over 5√2. Now in this case, what happens to the 5's? Yeah, these guys, these 5's would should be able to cancel just because they're fractions, right? If you have a 5 on top, 5 on the bottom, they will just reduce themselves and you get yourself a 1 over √2. Have we ever seen a 1 over √2 anywhere on a paper triangle? Interesting. Okay, cosine. Cosine would be, hey, x over r, which is same thing. So why write it when it's going to be the same thing anyways, right? 5 over 5√2. 5's cancel. Done. Whew. Tangent. Tangent is? Yeah, 5 over 5, which is 1. I should have put in the 5 over 5. Cotangent of 45 is 1. It's x over y, which is 5 over 5, which is also 1. Are we good there? I'm going a little too fast, but are you guys okay putting in the pieces? Okay. Secant is r over...
R over X.
r over x. Okay, so r over x is... Yeah, this one I probably should do here. This one. This should be 5√2 over 5, right? Now this time the 5's are gone, and I'm left with the √2. And what happens here is going to happen over here down too, right? So r over cosecant is the y value. Yeah, y value, which is 5. And we get ourselves a √2. Are we good? Okay, so then I got this interesting question. Oh, and then also you guys should remember this right here. So a 1 over √2, if you wanted to, you can write this as √2 over 2, right? That's just the rationalized version of these, right? And we did that in our little triangle, didn't we? We had 1 over √2, same thing as √2 over 2. Okie dokie. Let's jam. So hold on. So instead of putting coordinates like 5, and 6, right? I can just give you the angle measurement. Is that true? So give me all the trig functions, right? That are of a 45-degree value. We just did on the previous slide, right? So if you want to, you can kind of just put in this here. Just don't need to even put, let's see, two things I want you guys to do. On the homework, they kind of draw it out. And so what happens is they say, let's see. Let's do it this way here. So if you draw it out, you get to determine what coordinate you're at. We good? That's the way the homework does it. So it says for the 45-degree angle, you just have to be the diagonal of X and Y, right? And what they do is they just pick, they'll pick like 8, 8 as the number. We good? Okay, but we're smarter than that, okay? So if we go back to our values, sine of 45 degrees. And here's what I want you guys to do. I want you guys to just take out your triangle. Paper triangle, the one that we want is we want the 45, 45, 90 triangle. Is that right? And so what we want to do is we want to set it up just like this. We want to set up as going this way, 45 degrees. So now the question is this, what is our, so to make it just easier, we're good? And I wanted to transition you guys back to just kind of thinking about it in terms of angles instead of points. Because you're still going to get the same ratio, right? If the book will say 8, 8, who cares? At the end, we're still going to get the same answer. So if we just have a right triangle and you're going to open up towards the right-hand side, right? The wall is on the right side. What is our what is our length of our hypotenuse? 1. Okay, cool. What is our side values? Yeah. Oh, it doesn't matter. So 1 over root 2, we good? Oh, not in a decimal, is in fractions. Yeah, sorry. 1 over root 2, 1 over root 2. We good? Is that true? Okay. So sine of 45 degrees. Notice what happens here. If you have a length of 1, what's my y value? 1 over root 2. What's my r value? 1. Now notice with r being a value of 1, does 1 affect anything anymore? No. So notice what we can do is we can just put 1 over root 2. Are we good? Cosine 45 degrees is going to be the same thing, right? It's the x coordinate. Now, what we are doing, you're just using our triangle just to get us to a coordinates. We're good? That's kind of what we got. We have a coordinate of 1 over root 2 and another 1 over root 2. Because the length here gave us this one. True, true. And the length up gave us this one. Does that make sense? Right? How far we went along the x-axis is the first one. How long we went against the y-axis is our second one. Okay. Blah, 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 blah. Answer is the same. Anybody, what is tangent of 45 degrees? Thank you. It is just, it's weird because if we do it this way, it'll be 1 over root 2 over 1 over root 2, which is just 1. We're good? I'm going to pause just now. How you guys doing? Thumbs up if you're like, I'm getting this. This is super cool. Thumbs sideways like, yeah, I'm kind of like, and thumbs down is like, what class am I in? Okay, cool. I got this and I got some people like this. So cool. That's cool. That's okay. People like this, just come ask me just a little more, see what's not sort of flying there just real quick here. Okay, cotangent of 45 degrees. Let's talk about this here. So this one's going to be, again, it's all about definition though, right? This is just x over y, right? What's my x value? What's the length along the x value here? 1 over root 2, right? And the y value is the length here, which is 1 over root 2. And those are the same exact numbers, so there are just a 1. We good? So now we know this. Tangent of 45 degrees, no matter how big the triangle is, no matter how small, it's always going to be 1, right? It does not matter on the triangle. Okay, two more. Secant. Secant of 45 degrees is? Oh, it's 1 over root 2. What do we do there? So if it's 1 over like this, what we do is we try to change this into a multiplication symbol, right? So we're going to make this guy into a fraction. So how do we make a fraction of 1? 1 over 1. Perfect. Yeah, this guy stays exactly the same. We change it to multiply, and what we do is we flip this around. And the 1 is on the bottom, the root 2 is on top, and what do we have? Or just root 2. Are we good? Next, cosecant. Cosecant 45 degrees is the same exact thing. Is that right? Okay. Are we good? We're just trying to get connections here. So built off coordinates. Coordinates eventually go to angle measurements. And I don't care what the value is, because on the terminal side, it's always the same. The ratio is always going to be the same. Packers did something cool. Okay. What do we got? What do we got? Yeah, 2 more minutes. Let's go. Last one for the day. And we'll stop there. How about if I change it up to this? I'm going to give you guys a 135-degree angle. Hmm. All right, we'll do it together. This will be the last one here. We are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we have about 9 slides, no, eight slides left. But we'll do them on Friday. We're good? Yeah. If you want to start a little bit of the homework for 1.3, again, but we're not going to be done with it. The beginning part is going to be the easy part. Finish on Friday, it'll be due Wednesday, right? It's always two days, 2 school days. Okay. Let's finish out this one. 135 degrees. You go like this, you go like this. I don't see any numbers here. There's no coordinates here. But if I measure out 135 degrees this way, that's 135 degrees. And I make myself my little triangle. What's the triangle here? How many degrees do I need to go from 135 to give me to 180? Oh, this is so cool. Hold on, guys. It is still a 45, 45, 90 triangle. It's just in quadrant 2. So then here it is. If you hold up our little 45, 45, 90 triangle, Milo, can I have yours? Yeah. Sorry, just put it back. So now, if this makes sense, guys, all we're going to do is we're going to take a little triangle and we're going to put it this way. We good? So if this is it. If the side length here is 1 over root 2, right? The question is, what's my coordinate? Right? So let's take a look at this. So if the side length is 1 over root 2, my coordinate's going to be negative 1 over root 2. Are we good there? Thank you. And if we go up, which is the side length of 1 over root 2, but we're going up, we get ourselves a positive 1 over root 2. Are we good? So let's see if this makes sense. So the only change is that the x coordinate went negative. Everything else is exactly the same. So let's see if we can write this out. So sine of 135 degrees is y over r, right? Y is positive over r, which stays as 1 over root 2. See if that makes sense. Cosine, here's the change. Cosine 135 degrees is x over r, and x went negative on us. It became a negative 1 over root 2 over 1, which that's the only change. The only change was a sign change. Okay, tangent. Tangent is, yeah, essentially it's 1, right? It's y over x, right? This is a positive 1 over 2 over a negative 1 over 2, which is negative 1. Are we good? Cotangent, and we are done already at this point. Let's stop here because we are right at 25 out. We'll finish this off just a little bit later here. Try the homework. If you get stuck on it, that's okay. Let's see, maybe I can even show you when we can go here. We are 1.3.
Oh, it's like, oh,
You guys, you should be able to do up to 19. So if you want to write it down, 1 through 19 is what you got to do.
Thank you.
Sure, absolutely. See you guys See you guys on Friday. You are welcome. And